Good day to you. I am Professor Dr. Stambamani, Professor in Mechanical Engineering at Madanapalli Institute of Technology and Science, Madanapalli, State of Andhra Pradesh. I am supported by Dr. Muralidhar Singh, a Senior Assistant Professor, the same department where I am working. I am also thankful to the management of Madanapalli Institute of Technology and Science for permitting me to record the video in the smart classroom. This is one of the classroom available in the department with the latest state-of-the-art lecture videos, things like that. Let us get into the subject called network. What is a network? Sometimes people must say that some X or Y is having a good network. That means there is a link, there is a connection. So more in contact. This is sometimes we call it as a network. In the same way, network in engineering, nothing but a project to be completed. Okay, it contains or it requires more number of contacts, more number of links, more number of process to be done. That we always call it as a network and followed by the project management. Project management nothing but construction of a house is a project. Construction of a building is a project. Establishing a manufacturing process right from the scratch of a housewarming or a foundation to till the end of the project is completed is also called as a project management. It can be defined like this in a simple way. A project is any task definable, requires investment and expenditure for one or more resources and independent activities which must be accomplished to achieve the objectives for which the task or project instituted. This is the project management. Simply, you want to construct a house, there are more activities involved and the activities must be completed within the time frame. There are two basic planning and control techniques in a project management. One is called, they are also called as critical path, sometimes called the CPM, and program evaluation and review technique, PERT. These are the two techniques which are involved in the project management. Applications of project management goes like this, both PERT and CPM together. Research and development activities, equipment maintenance and overhauling places, construction of building, bridges and dams, setting up new industries, planning and launching new products, design of plants, new machines and systems, shifting plant from one location to another location, control of production in large shops, market penetration programs, organizing big programs and conferences. These are the advantages of project management or project planning. In the project planning, there are three basic things involved or technicality involved. One is the planning, scheduling and controlling. You must have planning process, you must have scheduling process and there must be controlling process. The planning process defines like this. This phase involves setting the objective of the project as well as assumption to be considered. It involves the listing of tasks or jobs that must be performed in order to complete a project under considerations. In this phase, in addition to estimates of costs and duration of the various activities, the manpower, machines and materials required for the project are also need to be determined. This is the planning stage. Next stage is the scheduling stage. Scheduling stage goes with start and finish of each activity. When to start and when to finish. The critical path on which activities required need special attention. Sometimes we need to give more attention to certain activity, certain process. That becomes one of the scheduling process. The third one, the slack and float for non-critical parts. The next process is controlling. Control of machines, input materials, control of the process to be done and then money requirement, all need to have some control over the project. The phase is exercised after the planning and scheduling. It involves the following: making periodical progress report is most important for any project management. Review every time, then and there. Reviewing the progress, analyze the status of the report, making management decisions regarding updating, crashing and resource allocation. These are some of the elements of process involved in a controlling. In the project management considered, we come to the real subject of project management. Here there are certain technology or terminology is under consideration. One is the network. It is graphical representation of projects and consists of series of activities arranged in a logical sequence and show the interrelationship between activities. Suppose you have a construction house. Okay, right from starting from this ground breaking ceremony till the house is completely finished, there are many activities involved. There are many works to be involved. Getting an approval, plan approval, generating the money, bringing many people from work, materials to be available. There are parallel activities that are likely to be considered or likely to take place. It becomes a part and parcel of the network. Another terminology is an event. An event represents the start or the completion of an activity. The starting and end points of an activity is called an event. Suppose if you take sports arena, there's an announcement stating that the running race starts at 8:30 a.m. event. That's the event is going to start at 8:30 a.m. That is the event. Suppose, for example, machining a component is an activity. Start machining is an event. Suppose you are going to switch on the machine is an event. It's not an activity. Completion is an event. Starting an event, completing an event. If you look at a small symbol here, event always represented by a circle with maybe a letter inside or a numerical value inside, and there is another circle showing some alphabets or numerical number. Between these two, some activity taking place. Okay, this is called the event or sometimes node. This will be starting point or node and the ending point of the activity, and is another node. Okay, sometimes people always call it as a tail end and head end. And this is a symbol to be used always. This is called the merger event. That means there are two activities taking place at different places and then converging towards the node. That means two activities completed coming to one end, and then from there some other activity is going to take place. This we call as a merge event. That means two activities converging or merging towards one particular event or node. This is called the merger event. The same thing is a burst event. That means an activity is there that is going out of an event or a node, that is always called as a burst event. These are some of the conventions that are likely to be used. One is the merger event. Two activities combined together and come towards one particular event and something is going on. This is also called the burst event. From the node, there are many activities going to take place. We have shown only two, but there are many activities which can take place from the one node. And this is called the merger and burst event, and this is called a dummy activity. That means dummy activity need to be done but may not be connected with the main activity. It must be hanging. One of the elements of the network diagram is also called the dangling. The dangling activities. What is dangling? Nothing but we have a network. Okay, dangling, we have an active node, an activity, node, and many activities. Okay, now something is hanging here. Is called the dangling. This activity is called as a dangling activity. Okay, sometimes we know there is an arrow. This we call as an graphic representation by node and arrows, sometimes dangling activity or sometimes dummy activity. So the dangling activity, it is also known as dangles or closely tied activities in project schedules. They are activities with either open start dates or open end dates. All activities except first activity of a network need to have predecessor, otherwise they will have open starts. Suppose this is a starting point, there must be a successive activity, there must be successive event. Without a successive event, it is not possible to start a project. In the network diagram, always you must have only move forward and you should not move backward. Network diagram, the diagram should be represented only in the forward direction but not in the backward direction. This is one of the elements in a graphical representation of network. Next is a critical part. One of the activities of the project management is a critical path. The definition goes like this. A critical path analysis is a special application of network analysis. It uses network analysis for scheduling, production, construction of projects as well as research and development activities. Besides this, it is used in certain other situations that require estimates of time and performance. This is the critical path method. Fine. While going through the solving the problem, you can able to understand what is the critical path, how to identify all those things. In the network analysis, again 3 or 4 terminology to be used is only the preceding event, succeeding event and concurrent activity. Suppose preceding event, this is a starting point. Okay, there is a node or an event takes place and there is an activity. Another node, many other activities going on. Sometimes we call it A and B, and of course this is an activity. This is the starting point of a project. This is succeeding point, succeeding event. That means once the starting is done, it goes to next process. This we call as a succeeding event. And what is prior to succeeding event is A. What is succeeding A is B. So when you come back here, from B it is called the preceding event. From there, from A it goes to B is called the succeeding event. So in an element of a network process, we have both preceding event and succeeding event. But there are some concurrent activity takes place in a project. Probably we call as a concurrent activities without any detrimental to A and B activity. You can always do some parallel activity concurrently. This we call as a concurrent activity. Okay, this is a simple network. Okay, the critical part is the overall time it will take to complete the project. It is the longest path in time to the network. In the critical path method, the approximate time for an activity must be known. You cannot have variation between activity. There must be a definite or almost equal to definite, or 98% or 99% of the time required must be known before going for the critical path method. This is a simple network. 1, 3, 2, 4, 5 and 6. Starting point is 1. There is an activity. From there, successive event is 3. There is an activity A. It carries 6 units of time. Maybe in terms of hours, maybe in terms of days, or in terms of weeks. Same thing here. From starting point is 1. This is a node. the succeeding event is 2. The project is activities B and it takes 8 units of time. Same thing here, from 2 succeeding event is 4. There is an activity C, it gains time, unit of time 10. Subsequently, from 3 there is a succeeding event 4, activities D, it takes 15 units of time. This is called assembly's network diagram. What is the critical part here is, in terms of the process to be done, the duration of the time, part 1, 2, 4, 5 and 6. This is one part. What is a part? There is no discontinuity in a project. This is called as a path. In this one, start from A, goes to B, from B goes to C, from C go to D. This is a path, there is no discontinuity. This we call as a path in the network diagram. You see here, both of the path 1, 3, 4, 5 and 6. This is one path. Another path is 1, 2, 4, 5 and 6. These are two paths, the simple network diagram. What is the total processing time? 6, 72. We take the processing time of path from path 1, 3, 4, 5 and 6, 72 unit of time. If we take this path 1, 2, 4, 5 and 6, what is the total unit of time? 79. Unit of path 1, 2, 4, 5, 7, 69. 69 unit of time. See the difference? This takes more time, this takes less time. That means you must give more attention toward the path which is going to take longest route or longest processing time. That becomes critical. In case any delay in this path 1, 3, 4, 5, 6, there is a delay, the complete project need to be delayed or it cannot be completed when at the time of requirement. This becomes the critical part in the process. Fine, we look at examples. Simple example of this, an analysis is a special application of network analysis. It uses network analysis for scheduling production, construction and research and development. Besides, it is used in certain other situations that require estimates of time and performance. The path of longest time sequence is called the critical path. Okay, that method is called the critical path method. Let us see what are the advantages and disadvantages. Any process, there is going to be advantages, limitations or disadvantages. Advantages of this method is it figures out the activities which can run parallel to each other. I already told you what is a concurrent activity. It helps the project manager in identifying the most critical elements of the project. It gives a practical and displayed ways which helps in determining how to reach the objectives. CPM is effective in new project management. CPM can strengthen a team perception if it is applied properly. Again, advantages. CPM provides demonstration of dependencies which helps in the scheduling of individual activities. It shows activities and their outcomes as a network diagram. It gives a fair and concise procedure of documenting of projects. An explicit and clear approach of communicating project plans, schedules, time and cost performance is developed. It is extensively used in industries. It helps in optimization by determining the project duration. Of course, there are advantages, likely we have limitations or disadvantages. These are the disadvantages of CPM method. The scheduling of personnel is not handled by the CPM. In CPM, it is difficult to estimate the completion of time of an activity. The critical path is not always clear in CPM. For bigger projects, CPM networks can be complicated. 2. It does not handle the scheduling of resources allocation. In CPM, critical path needs to be calculated very precisely. This is a problem we are going to look at. We are going to solve a critical path method problem. I have taken the problem from the operation research by S. Kalavadi book. Okay. Now, these are the activity and these are the duration, time in days given. Activity 1 and 2, duration of time is 4, 1 and 3, 1, 2 and 4, 1, 3 and 4 and so on. Okay. There are up to 10 activities that are likely to take place in a project. We need to draw the precedence diagram and then find the critical path and total project time. This is a problem, a simple problem that we are going to discuss now. Before starting a problem, it is better to have a precedence table. Then it becomes easy for people to draw a graphical representation of the network. Activity 1 and 2, starting time is 0. So there is no preceding event, it is only succeeding event. So 1 and 2 preceding event is 0, 1 activity before 1 is 0, dash and succeeding event is 2, it is going to take 4 units of time or 4 days. Once 1 and 3, starting point of a project is again 1 and next successor event is 3 and preceding event of 1 is 0 or nothing. And unit of time taken, preceding unit 3 unit of time is taken is 3. Like this, it is better to have a table showing the preceding and succeeding events. Then it becomes easy for the people to draw the network diagram. Okay, we'll close this. Fine. The precedent diagram is table is shown at the corner. We saw the network diagram. The starting point is 1, 2. 1. The succeeding event is 2. And activity is here. It takes 4 units of time. This is the starting point. Succeeding event is 2. And time taken duration is 4. The next is 1, 3. So starting point is 1. Succeeding event is 3. It takes 1 unit of time. Succeeding event is 3. Preceding event is 1. Next is 2 and 4. That means some activity need to take place from the event 2. So we call it as the 4. This unit of time taken is 1. Preceding unit of 2 is 4. Succeeding unit of 2 is 4. Preceding event is 2. So 1 and 3 and 4. Okay. From the 3 event, succeeding event is 4. So we are going to join these two. 3 event and 4 event by an activity. The duration of the time is 1. Fine. Next is 3 and 5. Again, there is an activity which is going to start from the node. We call this a 5. The duration is 6 days. From there, another activity is taking place 4 and 9. 4, another activity is going on. We call this a 9. Duration is 5. Another activity taking place 5 and 6. So it is going to be an activity 6. The duration of the project is 4. From there, 5 and 7. Another activity is going to take place maybe the project time is 4 units of time. time is 1. 7 and 8. So there is an activity between 7 and 8. So this is joined here, and duration of the time is 1. Next is 8 and 10. So another activity is going to take place from here. This we call as a 10. The duration is 5 minutes of time. And 9 and 10 is another activity. That is what is going to take place. 9 and the duration is process is 7. In this case, the length of the arrow is no matter. There is no relation between the length of the arrow shown here and the unit of time given. Maybe sometimes we see here, I made a little bigger here and smaller here and smaller here. So the length of the arrow does not matter with the activity that is represented with the network diagram. Right. If you see the paths 1, 2, 4, 9, 10 is one path. 1, 3, 4, 9, 10 is another path. 1, 3, 5, 6, 8 is another path. 1, 3, 5, 7, 8 and 10 is the another path. If you look at the duration of the path or the time taken to complete one path, we are able to calculate it and you know what is the critical path. Suppose go to the path 1, 3. Okay, we already done the network and also path. We go through the path 1, 2, 4, 5, 6, 1, 2, 4, 9, 10. It takes 17 units of time. Add this unit of time there. Another path is 1, 3, 4, 9, 10. It's going to take 14 units of time. And 1, 3, 5, 6, 8, 10. It's going to take 17 units of time. And 1, 3, 5, 7, 8, 10. It's going to take 22 units of time in terms of days. If you look at the paths, the longest path is 1, 3, 5, 7, 8 and 10. But other projects you can able to finish within the time frame, whether this is going to take longest time. So this becomes the critical path method. More attention to be given. In case of any delay from the project, this rule, then definitely the project is getting extended to complete. Okay. In order to show that, normally it is shown by double line. If any project network, if you see the double line, that becomes the critical part. Sometimes people always put what is called the bold or a block line. That means that is the critical part. Management or the person who is going to execute the project must give more attention towards the longest processing time or longest path. This is what we call as a critical path method. So I can able to explain to you the critical path method in a simple process way. Okay. Thank you very much for watching. We will see you after some time with different videos. Thank you once again.